Today's another one of those days around the shop here where we got to brainstorming and we came up with a new tool, okay? And this tool, by the way, we developed to help us detail the engine compartment in this W113 280SL of mine. And there was no other tool that could do it. I mean, I get tired, by the way, of grabbing a hold of sandpaper or Scotch-Brite pads and rubbing around in an engine compartment trying to detail it and banging into something and gouging my skin. And this is obviously the reason I wear gloves, but even then you can really hurt yourself. So I wanted something different, and so did my mechanics. So we came up with a new tool right here. Now I'm not going to explain everything about this tool because I've shot a companion video today. I will put a link below explaining what this tool is and what it does. I would have never believed, if you would have told me 20 years ago when I first started working with Mercedes, messing around with these cars, that I would end up spending my twilight years making specialty tools to work on Mercedes-Benz, I would have laughed at you. I had no idea. But this all evolved over the last 15 years. And as I show you some of these tools that we make here, you'll get to see a little bit of the evolution and the reason really why I ended up developing these tools in the first place. The very first specialty tool that I designed almost 15 years ago is this wrench right here. This is a wrench for adjusting the valves on the older Mercedes diesel engines. Now why did I develop this wrench? Because I didn't like the way the German Hazet wrenches work. They hurt my hands, the heads were too wide, you couldn't get them on the nuts. So one day my mechanic and I said, let's make a wrench. And we started out with, a 14 millimeter combination wrench, cut it off, weld it on a pipe handle, and then we had to go through all this monkey motion to heat and bend this with a torch, okay? Then we did some other modifications to it too, and as we started using this ourselves, I says, wow. We also had offset heads. When we made it, we made it so the heads were offset, and that's something the German wrenches didn't have either. So you had this give you a much better options to get on those two nuts. And over the next 3 or 4 months, we said, this tool works so well, let's make it and sell it. And I don't know how many thousands of these sets of valve adjusting wrenches we've sold over the year. But we're really proud of this tool, by the way. This is totally made in the USA. The wrench is a US-made wrench. The pipe is made here. It's a specialty pipe made here in the US. And even this heavy-duty rubberized handle material is made in the US. So that's hard to say anymore, where you got everything made in the USA, including all the materials that go into producing it. So right behind that tool came another tool. Some of you may have seen this on my website, some of you may own it. But as I worked on these old diesels, one of the things that was really hard to get off were the bolts on the fan clutch that held it to the water pump. And you have to change the water pumps in these old diesels. And getting on those specialty bolt heads was very difficult, and even reaching down in there to get to them was not a piece of cake either. So we went to work coming up with a very long box end wrench, once again cutting off a combination wrench, welding on a pipe, and then we had to grind the head because there's very tight tolerances. I don't know how many rounded off fan clutch bolts I've seen over the years because people have tried to get them off with an open end wrench. So that was number 2. And then right behind that came a set of tools to take the oil cooler hoses off the old diesels. Oh boy, was that fun. Trying to get those oil cooler hose fittings off back there on the oil filler. So look what we had to do. We came up with this box wrench that we cut out so we could get it over the line on those oil coolers, and once again put a handle on it. Then we had to have a specialty wrench that would hold the nuts on the oil filler housing so that when you turned the nut on the oil cooler hose, that wouldn't spin, and it had to be really thin. So we do some special cutting here in our shop to modify this wrench right here. But if you're changing oil cooler hoses or pulling off the oil filter housing to replace the gasket, these tools are real lifesavers. Next up was the fuel tank screens in these old Mercedes. So many of them need to be removed and cleaned or replaced. And trying to get the fuel tank screen off is, people said, well, just get under there and use a spanner wrench. Well, sorry, it doesn't work that way. It's really hard to get up there. There's a rubber gasket gets in the way. And a standard socket doesn't work. The standard socket is too deep. And it also doesn't have a sharp edge. You don't have very much of a lip on that tank screen to get on it. So we have to cut this to a sharp edge so that when you get up on there, you can get that and you can break it loose. The other thing we did was put a standard 17 millimeter bolt head on the other end of this so that you can use a box wrench, because most people don't have 3/4 inch breaker bars or 3/4 inch ratchets. That's what these bigger sockets are when you go out to buy them. So this has been extremely popular. I mean, we've sold hundreds of these over the years. So once again, this was developed because of frustration trying to get the fuel tank screens out. Also, we found out, very quickly that this also works on the fuel tank sending unit. And some of those fuel tank sending units, particularly like on the 116, 123, are hard to get to. You certainly can't get a wrench, a standard wrench down in there. So by the way, this socket also works on fuel tank sending units. Okay, then along came the need for reamers. Reamers to ream out the glow plug holes. And I didn't like any of the reamers that were available on the market. And there wasn't even a reamer available for the old series style plugs, the large ones. So these reamers, we've sold thousands of these reamers. We get the housings out of Germany. We machine the housings out. We buy the reamer stock and we press fit in the reamer into the housing and get it all aligned properly. So this is a real must for you diesel owners. Anytime you're changing glow plugs, or if you're having hard starting issues, you want to make sure you ream the carbon out of the pre-chamber before you install a replacement glow plug. So reamers. Okay, along with another tool we came up with was a drip tube. See that little drip tube? We buy the stock out of Germany in straight stock, and we bend and cut these to make a precision drip tube for adjusting the injection timing on your older diesel too. And I suppose it was about 8 years ago, 8, 9 years ago, that this became a real need right here. Okay, we started getting into rebuilding diesel fuel injectors. We started selling replacement nozzles from Monarch in Germany, along with kits, shim kits, and tools to rebuild your fuel injectors. But let me tell you, without a pressure tester, this was really difficult. And at that time, the pressure testers were, $300-400 that you could buy. But this has been a really interesting evolution over the last 8 years. It went from originally being just a tool to test your diesel fuel injectors, and then within a few years, we found out by changing the gauge, you could test the CIS fuel injectors. See whether or not they were sealing properly, see what the spray pattern was like. And then recently, if you've been watching my other videos recent videos on YouTube, on my 6.3 and my 280 SL, taking the mechanical fuel injectors out and testing them, it can be done with this tool here too. Changing the gauge, changing some of the procedures. So this is made here in my shop. We take this apart, we have to modify the bottle jack, we have to get all these special fittings, we manufacture this line here, we have to get the right gauges. We use liquid filled gauges, by the way, now to help for the accuracy of the reading while you're building up pressure to test your injectors. So we can now test almost all gas and diesel fuel injectors from the early 1950s right up to the late 1990s with this tool right here that we build. A lot of them. This is very time consuming to build this, by the way, and we have sold, I don't know, I wish I would have counted how many hundreds and thousands of these pressure testers we've sold, but we just keep cranking them out, building more every day, okay? And then we had, we got into turbochargers, and we found that you needed some special tools to take these turbochargers off the engine. This is one I came up with to help torque the nut on the end of the turbine shaft, because it has to be torqued to a specific torque, and while you're holding the unit in the vise, you need a steady pressure to apply the torque. And there's two different sizes. There's two different sizes of nuts on most of these T3 turbochargers. So look at what I did. I took two different wrenches, welded them together, provide a nice T-handle to apply the proper torque to that nut on the end of the turbine shaft that holds the compressor wheel in place. Then, of course, we needed some other tools to get to those nuts in the center section. And of course, once again, what we're doing is we're taking wrenches, existing wrenches, and bending and modifying them to help you get your turbocharger, your diesel turbocharger, off the engine and overhauled properly. And then it seems like more recently, one of the best breakthrough tools that we did was this shift bushing insertion tool. I mean, trying to change these shift bushings up underneath the car, up in the transmission tunnel, is really challenging. So we came up with a tool to take the clip off and a tool to both remove and insert the shift bushing, and these have been extremely popular. Then right behind that, we've done some other specialty pliers. This is the curved tip plier. You can't believe how handy this is. It can get a hold of things to remove, but plus you can grab stuff in real tight places. And then the clamping tool, which has been so popular, gets hoses loose, coolant hoses, small rubber hoses, fuel hoses, also gets a hold of spark plug wires, and you can remove them like from the M103, M102 engine. So we're still working. Recently, this is a simple one. This removes the glove box nuts on the 123 and the 126 chassis. You ever tried to get one of those little nuts off? So I said, hey, come on, let's make a tool that makes it easy for the poor guy out there working on his own Mercedes to be able to get that glove box off. Currently, we're working on some other clamping tools. We have found that clamping tools like this are extremely helpful working around the shop, working on cars. This one we developed working and rebuilding diesel fuel injectors. We needed a way to get a hold of these things. Let's say you're cleaning these in preparation for overhaul, and see you've got a lot of rust and junk down in there. Well, you need some way to hold on to this while you run a drill with a brass brush in and out. And so this clamping tool, by the way, has become so handy around here. See, it's a much larger size than the other one for the spark plug wires. And it's also got a little bit more of an angle, but you can grab a hold of stuff when you're working on things. And with these long handles, this really gives you the torque to hold on. So if you've ever used a grinder or a wire brush, and you try to hang on to this while you're grinding or wire brushing and get your fingers in the wire brush or grinder, you know how handy a tool like this can be. So this has become our #1 tool, by the way, when we're working around our grinders and wire wheel brushes. We just welded up one of these larger grab tools today in the shop, and what we're working on now is the angle. See that angle? That's critical, because if you get too straight an angle, you get maximum pulling force, but it doesn't give you the flexibility to get around in tight places. If you get too great an angle, then you don't have good straight pulling force, if you follow me. So we're playing with this angle right here. But what we started out with to make this tool basically was a 21 millimeter box end wrench and a big, long needle nose pliers. And you think, well, that's really simple. Well, it isn't. You have to cut the wrench, you have to split the box end, you have to cut the tips off the long needle nose, then we have to grind a notch, then we have to set them up in a jig, and then we end up welding them to get the right angle and the right alignment on the end. That's critical, and this isn't as easy as you think. If some of you have done some welding, you know that it's never as easy as it looks. In fact, one of the things we laugh about is, you can weld and make any weld look pretty and spend hours grinding off excess weld. Well, if we're going to do this and do it economically, we've got to be able to, put a good bead on there that we don't have to spend half hour grinding away all the uglies, if I could say that. So we're in the process here. We're still working on some different ideas with this. One idea we came up with was, how do we grab a hold of something that you want to protect, that you don't want to score? So what we use is a piece of rubber heater hose, and you split it, and you can put this in the jaws like that, and then let's say I'm going to clamp down on this wrench for some reason, say, and then I can come in here and like this, and then, see, I've got a hold of this, so I can bring this up to the grinder or the cutter and keep my hands away. So this is what has become such a popular tool here in our shop, just as we work on building other tools, okay? So now, I want to show you a couple more tools before I wrap this video up that we build here. One is quite complicated. It's one of the more complicated tools we make. It takes a number of different steps. And then I'm going to wrap it up showing you one really simple one that does actually solve a real frustrating problem. Let me give you a little background on this tool I'm going to show you. This is a diesel, a 617 turbo diesel pre-chamber. If you've been around diesels, you may recognize this. This fits down in the cylinder head, and this is the collar nut that holds the pre-chamber down tight. There's a washer, a crushable washer that goes here, and what we were finding is we're starting to develop leaks. You'll see little bubbles coming up around. If you look here, this is where the fuel injector goes. So now for some of you, this will make more sense. You see, this is the part that the diesel fuel injector screws into. And if you look at your engine, and while it's running, if you see little bubbles and little bit of fuel seeping out around these threads, it's usually because either this is loosened up or the seal's not sealing. So I remember the first time I took one of these collar nuts out, I tried to rig up some sort of a tool, a spreader tool, and then I realized this is in there with well over 100 foot-pounds of torque. And I can remember I was so frustrated I had to get one of these out that I used a punch. And I got a punch on here and literally, got it out, but literally destroyed the collar nut. So the challenge was to come up with a tool that could tighten this collar nut and then remove the pre-chamber. The only way the pre-chamber can be removed is to pull it out of the head with a slide hammer. So I went to work. We started thinking about, okay, what do we do? Let's start out with this, coming up with a tool for the collar nut. So I knew it had to be really, really tough steel. So enter a large, heavy-duty impact socket, very strong steel. So how am I going to machine this so it will fit down in these notches in the collar nut? So then we had to go to work on a CNC machine to machine out this socket. And this is what it looks like after it's been machined. But the problem here is, see, those are straight cuts and it doesn't fit down tight. You've got to have these two notches fit down in here at an angle and be real tight on there. So, okay, that took the next operation. So we had to grind. We had to machine an angle in these two notches, and now this fits down in very tightly. See that? Fits down into that collar nut, because if it doesn't fit all the way down in there, you're going to turn this and it's going to break off these edges of the tabs. And then the next operation, of course, was to weld a large nut on here so you could get a wrench on there and turn it, okay? But you had to have some way to hold this tight, because if you just stuck this on here and tried to turn this with a socket, it would just slip right out. So enter the next phase, where we had to come up with an adapter that would screw in to the pre-chamber like this. And then you slip the collar nut tool on over the top, let's say here's your collar nut, okay? Slip this on over the top like that, and then taking this nut and tightening this down, what this would do is it would keep the tool tight on the collar nut while you took a wrench or a large socket and began to turn it. And of course, as you turn it a little bit, it doesn't take much to break it loose and then it comes out, but you can adjust the tightness by tightening and loosening this nut here. So we found out very quickly, well, we could modify this one tool to get the pre-chamber out by welding this on to the end of a slide hammer. So using this same threaded tool that we use for the collar nut tightening and loosening, we ended up providing an adapter, welding it on to a 2-pound slide hammer, and then you hook this up with a slide hammer and slide it off this way. So this is a really good example of an evolution of a tool that we make here at Mercedessource. And like I say, this is one of the more complicated ones that we do here. It has the most steps and is probably the most expensive to produce. Now let me show you the easiest one that we do here. I'm sure many of you will recognize this. This is an engine instrument cluster. This one's out of a W116. They're very similar, the 123, 126. And we've gotten a situation where we need to work on these instruments, and lo and behold, how do you get these needles off? Anybody ever try to get one of these off? Try to pull it off? and look, I already damaged it by pulling on it. See that? It bent it. They're kind of fragile, but they are really on there. So it was back to the drawing board, figuring out how can I get in behind and actually pop it off from the back side. You know, you can't use a large tool because you don't have a lot of room to get down in behind here to get to the back side of these needles. So I just took a screwdriver here, made a simple notch modification, and watch this. As I go ahead and get this oil pressure needle off, I can go right down in here behind, get underneath that needle, and then pry up on it. And I'm going to very carefully pop it off like that. There you go. And so that is an example of solving a problem with another very special tool that we build in our shop. And I provide this tool with a full set of instructions on how to remove and replace one of these oil pressure gauges, which are becoming quite a problem on the W123 chassis. So I think you saw a good selection there. We have a lot of other tools that we make here at Mercedessource. I'm going to put links in the show more description at the end of this video if you're interested in learning more about these or purchasing any of them that I've shown in this video.